Hello, this is John from caveofprogramming.com. In this tutorial, we're going to look at our actual fractal algorithm. So we've got the stub of our Mandelbrot class here, and we need to implement the Mandelbrot algorithm here. So let's go ahead and do that. Now, you can do this without complex numbers, but I'm going to do it with complex numbers because that makes it a lot simpler. I'm going to include complex, which is a built-in C++ complex number class. And I'm going to say using namespace standard. So I will attach a PDF explaining complex numbers a bit with this tutorial. But if that doesn't interest you, you don't need to understand this stuff just to type it out and use it. It's not like it's vital to know this for C++ or anything. Another thing you could do is you could implement this just by Googling it on the internet. You know, Google something like Mandelbrot algorithm or how to plot Mandelbrot or something. You can implement it without complex numbers. If you do that, one thing to watch out for is make sure that you don't mix up the results of one calculation with your previous calculation. That won't mean anything to you now maybe, but if you do try to implement this without complex numbers, I would keep that in mind. So remember, you have to calculate two values separately for x and y if you don't use complex numbers, and that's tripped me up so many times that I'd recalculate x and then accidentally use that when I'm calculating y, when you need to do both separately. Anyway, let's not worry about that. So if you don't have this header on your system, then you'd want to Google Visual C++ complex class or something like that, you know, find out what the equivalent is for your C++ compiler. So I'm going to create two complex numbers here. Let's create one called Z. Let's say complex. This is a template class, and we need to say, because each complex number is actually a pair of numbers, then we need to specify the type of each of those two numbers that make up the single complex number. And I'm going to use double here rather than int or float or something. And let's say Z equals 0. So Z is a traditional letter to use to represent a complex number, and this is an overloaded equality assignment operator which just sets both of the pair of numbers making up this to 0. We're going to need another one, so let's say complex double C, and this one I'm actually going to use the constructor of this and pass in the pair of numbers to initialize it with, and I'm going to use x and y like that. This is just this purely has to do with the Mandelbrot algorithm. And next we'll create a number which I'll call int iterations, and I'll initially set that equal to 0. So I won't get into this in detail, but just to give a really quick explanation, what we'll do is we'll apply an algorithm involving these numbers, which are obviously they're going to be, well, C is going to be different for each particular pixel. And we're going to see how many loops we have to do before a number starts shooting off to infinity. We'll see how that works in a second, because that's the number of iterations of that loop is what we're actually interested in. So we'll say while iterations, and we can't obviously iterate until infinity, so we're going to have to cut it off somewhere. So I'm going to say while iterations is less than max iterations. This is the constant that we defined in Mandelbrot.h. I'm just using the autocomplete control space there on my Mac, and it's the same on Windows, I think. So now we're going to square this complex number. We're going to say Z equals Z times Z plus C. So initially Z is 0. Both the numbers that compose it are 0. We're going to keep multiplying it by itself, which is the equivalent of squaring for a complex number. We call it squaring, and then add C to it, which is going to depend on the actual coordinate of the particular pixel that we're dealing with. And we're going to do that over and over again. And there are rules that define how you add and multiply and so on complex numbers, so they're just arithmetical rules, nothing really difficult. But obviously it's a bit confusing if you see this for the first time and you say, okay, so this is a number which is made up of two numbers, how do we multiply it by itself? Well, there are rules for doing that, which you can find in the PDF that I'll attach with this video. Now, there's also a notion of the absolute value or the magnitude of a complex number, and that's defined in such a way that actually if you plotted the two numbers that it's made up of on a 2D coordinate system, the magnitude of the complex number is actually the length of the line from the origin to that point. That doesn't matter too much because we've got a handy function built into C++ called abs, which gets us the magnitude of a complex number. And again, if this doesn't work for you, then you just need to Google how to get the magnitude of a complex number on your particular compiler, because I'm sure pretty much every C++ compiler has got to have this. We're going to say if that's greater than 2, then we're going to break the loop. So there's this set of numbers, set of pairs of coordinates, if you like, which we bung into this complex number. So let's just put break in there. And for some of these numbers, no matter how many times you do that, it will never exceed 2. And these numbers are in what we call the Mandelbrot set. However, for some values, for some pairs of coordinates, this will exceed 2. And it happens that if it exceeds 2, that means that if we kept doing it, it would simply tend towards infinity. Whereas if it remains below 2, then we say that this pair of numbers is part of the Mandelbrot set of numbers. And we know that then that they will remain bounded, the numbers in that set, no matter how many times you do this. We can only afford to do this loop a certain number of times. We can't go on forever, but we're doing the best we can here. And you can fiddle about with this max iterations to get the best results. So if the number is not part of the Mandelbrot set, that's where it's really interesting. If it actually starts shooting off to infinity, the value of it exceeds 2. The magnitude of this complex number exceeds 2. Well, that will happen after a different number of iterations, depending on your x and y values that you've put into this constant, this value here. And it's that number, the number of iterations it takes to reach this point, that we're going to map to a colour, and we're going to see how interesting that really looks on the screen. So as I say, you don't need to understand this, but I'm just trying to explain a little bit just in case you're interested and you don't know this stuff. One thing I absolutely mustn't forget, which would definitely screw it up, is to increment the number of iterations here. Otherwise we've just got an infinite loop. So we're going to keep doing this, and we're going to increment this every time. And we're going to keep doing this little bit of maths here, and finally we need to return the number of iterations that we had to do, either to reach max iterations or else to get this value to exceed 2. Okay, let's build that and check that it builds. So it does build, looks okay. Now I'm going to go back to main.cpp, and we're going to use that. So we're going to say int iterations, and it's a static function. So Mandelbrot, we made it static, : get iterations, and we'll pass in our scaled x fractal and y fractal coordinates here for this particular pixel, whatever pixel we're examining within this nested loop at the time. Now we need to map that to a color. So let's use a uint 8_t, and we need to include, of course, up here at the top of main.cpp, we're going to have to include C standard int, or the equivalent for your compiler, but it's probably got the same name on there. Let's call this, let's say, red. I just want to see something on the screen at the moment. I don't care if it's not so pretty, just as long as it looks like a Mandelbrot. So if we put that equal to iterations divided by max iterations, let's say Mandelbrot : max iterations, we made it public so we can do this, it's constant. This is integer division. It's integer division, so it wouldn't give us the results we expect. It would, I guess, always be 0. What we need to do is make one of these double, so that we've got floating point division. We could use a fancy sort of modern cast, but I quite like doing it the old way, to be honest with you. Let's just put in double here in brackets. So if we cast that to a double, this will be applied, that cast will be applied before the division. It has priority. It has a higher, a higher priority. Then we'll get floating point division, and this number will now, because iterations can be at most max iterations, this would range from 0 to 1. So if we then multiply that by 255, then we should get a number that's it's going to be a floating point number that's going to range up to a maximum of 255. What we can do is change this to 256 and then just cast the whole thing. Let's put brackets around the whole thing. Cast it to uint8 underscore t. Let's try that. Well, normally I just put int in there because that also works in this case. And I quite like to check that this red value is sensible. So let's use this minimum and maximum stuff, which I had a feeling would come in handy, and see what red ranges over now. See if it does range from 0 to 255. So we'll run this. We've got some error here, so I did something wrong. User undeclared identifier Mandelbrot. I just need to include, I'm always forgetting that. I just need to include here. I'm really glad that C++ isn't one of those things where you have to be sure that it's right before you run it, because I would be just terrible with that. Okay, let's go and add Mandelbrot.h. There we go, Mandelbrot.h. So I'll build that again, and it looks okay. So let's run it. So now we've got well, this is now going to be quite slow because we're doing a lot of calculations, and especially when you've got loops in there. So it's ranging from 0 to 254, which well, I'm not quite sure why, but we've got this slightly complicated algorithm in there, and that's pretty acceptable, really. It doesn't have to absolutely hit 256. So we could fine tune that later, and we're going to put some more complex colouring code in here, which is going to give us some more practice with C++. But for the moment, that will do. Let's plot that on our bitmap. So let's say underneath this, bitmap.setPixel. So we need the x and y coordinates, and those are the original x and y coordinates, because those are the ones that range over our entire bitmap. And then we've got our colors. So let's put in 255 for, well, let's put in red, and for the others we could try 0. And now that I think of it, red might be a bit of a mistake because it's not going to show so well here. We'll try this and see how it looks. So let's just run it. And so we're just looking for something on the screen at the moment. It's not going to be that pretty, but hopefully we see something on our bitmap. So if we take a look, now we can see something there, and it does look like a Mandelbrot. You can hardly see it, and it's not that pretty, it's not that interesting, and it's even a bit off the screen. We're going to fix all those things bit by bit, just for the moment, just so you can see this even more clearly. Let's maybe let's maybe just set all the values to whatever red happens to be. So this is hacked around a bit, but I'm carefully limiting my hacking to this little region, and we're going to very soon remove the sort of hacky stuff, but we're just experimenting a bit at the moment with this stuff and with this stuff. Let's try that. And another thing that has helped me previously, although I haven't tried it in this particular program, is just squaring the color value. That can also work, but come to think of it, if we do that, well, we're going to have to scale red again. So let's not do that on second thoughts. Let's just run it, see how it looks. Hopefully you can see this in the video, that we've got something there, and whatever you get, it should look approximately like this. It's slightly off the edge of the screen, so we haven't really got the kind of viewport set very nicely, but most of it's on the screen. And we can see that we've got a sort of head here, the head of the Mandelbrot, and here we've got the body, and we've got all these little sort of things that look almost like feet or something coming off an animal all around the edges. They also look rather like small Mandelbrots protruding from the edges. And you can see that the Mandelbrot also, if you look at the body, it's almost like a heart shape. So if you get the algorithm right, it will look like that. If you get something that's, it's got a sharp cleft in the center that comes to a sharp point, and it looks like a sort of two wedges, then you've done something wrong. You probably used the value of x. If you did it without complex numbers, if you accidentally use a value when you're calculating the new value of y, because without complex numbers in here, don't worry, I'm going to stop waffling in a minute, but in the actual algorithm in here, if you do it without complex numbers, you have to recalculate values for x and y every time. But you have to remember that once you've calculated a new value for x, then you can't use that in calculating the new value for y. You have to use a temp variable and separate them. And I found when I did this before that leads to a horrible sort of wedge-shaped thing. So if you've got this far and you typed out the code and you've got something that looks pretty much like this, then you've probably succeeded, which is good. Okay, so I'll leave it there for this tutorial, and I'm not sure what we'll tackle in the next tutorial. We might get on to colouring this a bit more nicely, and we're certainly going to have to make sure that the whole thing fits on the bitmap. So that's it for now. Until next time, happy coding.